Hello everyone, welcome to this video. My name is Amirson Ahrari. I'm a Google Earth Engine expert. In this tutorial, I'm going to show you mosaicing process in the Earth Engine platform. This tutorial can be used for those of satellite data that have framing structure such as Sentinel and Landsat data. And also this is one of the typical questions that most of the users asking how we can do mosaicing process during in a time series analysis or the data analysis we want to do in the Google Earth Engine platform. This is a very simple and applicable tutorial that is very useful for beginner users who are working with the Earth Engine. So first of all, I'm gonna select a province as a region of interest. For example, I'm gonna select a province in the north of Iran. Here you can see here we have a region in the north of Iran that you can see in the map. You can search it easily, or you can find your own special location or region of interest. This tutorial can be used for all around the world, not limited to a particular region. The data available for whole of the world, and also you can use the codes for everywhere you want to work. So first of all, I'm gonna select a province that you can see here, but I have no shapefiles for this province. It's very simple. There is a simple solution. Go to search places and dataset and look for FAO administrative layer. FAO administrative layer. Recently, I published a video on my YouTube channel explaining about the different methods for the region selection using basins, using administrative borders, or using drawing tools. You can find it on my YouTube channel, and there are the other tutorials helps you to get more information about Earth Engine. I'm trying to share my knowledge in the Earth Engine with all the users in all around the world. If you had a still problem, you can reach me out on YouTube channel and put your comments there. I will check and back to you soon. So back to the tutorial. As you can see, global administrative layer unit is available. Just importing into the code. Two types of shapefiles is available. One of them is normal layer, and another one is a simplified version. The simplified version for the cloud computing or dealing with satellite data on the Google Earth Engine platform is better than actually the normal shapefiles, because the simplified version is very suitable and configured for the cloud-based analysis and helps you to avoid any problems or speed problems during the process on the Earth Engine. As you know, the speed of processing in the Earth Engine recently got very important because as you know, we are using the open version or unpaid version of Earth Engine, and it is very important to able to manage the resources you have access in the Earth Engine freely. So one of them is try to use those of shape files that are simplified as much as possible. So accordingly, the first level simplified version imported, and then through the map.add layer, I can visualize all the provinces available in the table. So just run a code using map.add layer. After a few moments here, you can see the province borders. But when you want to select a province and separate it from the other provinces, there is a very simple trick here. Instead of using clipping process, just you can mark your region of interest like this easily, and then try to filter your region of interest using filter bounds. So make a new variable as ROI, bring the table, and then filter it based on the marked region. Meaning that I'm gonna select the region that is marked by marker tools already, or drawing tools you can see here. The marker named as a geometry here, and then put it inside the parentheses. Finally, then you can have a new map.add layer, this time for the ROI, and then you can have focus on the region of interest through the center object function, just like this. run a code again, and after a few moments you will have a new region of interest that is the selected province that you can see here. So there it is. This is the first step, how to find your region of interest, because most of the time when you are working in a basin or province, you face with such kind of errors. For example, specifically with mid-resolution satellite data such as Landsat and Sentinel, which have a framing structure, you can see a part of your image is missed because of the image frame size is smaller than the size of the region of interest. That's why most of the time we face with the issue. And this is important question, how we can mosaic whole of images covering our region of interest, and then how we can clip it based on the border we have. And this is one of the important questions that I want to point out in this tutorial. So now in the next step, I'm going to call Sentinel-2 data with 5 or 6 days temporal frequency. So here Sentinel-2 variable created, back to search places and dataset, and type for Sentinel-2 data. As you can see here, Sentinel-2 level 2A is available, imported into the code as an image collection. Now as you can see, I'm assigning the image collection to Sentinel-2, and now I'm gonna limit or bound my data to a period of time and a space and also location. For example, first of all, through the filter date, I'm gonna filter the data based on a year starting from 2023 and ending to 2024. In such kind of filtering process, 2024 images are missed, and only we have focused on 23 images. So then you can filter your satellite data based on region of interest. As long as your satellite data has framing structures such as Landsat or Sentinel, feel free to use filter bound to bound your data, or try to call your data based on region of interest you are working in. So here that filter bounds based on a ROI, because I need those of satellite data available for the whole of region. So there it is. So take a print first, and here we have a Sentinel-2 image collections. In the right panel you can see how many images for 1 year of this area is available. Around 1000 images, or 927 precise data, precisely satellite image is available for this region of interest. And also this is a little tricky because the temporal resolution is between 5 or 6 days, and also it is far from our expectation to have 1000 images for one location during a year. Even your data has a daily temporal frequency. In that case, you must have 365 images instead of 1000 images. So what the problem is? The problem back to framing structure, meaning that in this area we have couple of framing with actually each one of them covering a part of the region. That's why we have large number of data that we need to organize them using the for example, framing structure, framing management through the mosaicing process. So now I'm gonna actually make a list of all satellite data that we may have during one year, and then I'm gonna actually filter them based on the temporal frequency, temporal resolution in Sentinel-2, and then I'm gonna do the mosaicing process for each period of time that we have a Sentinel-2 image for different region, and do the mosaic process then. So here let me to make two different variables for the time start, for the starting and ending. Here we will have a new variable as time start earthengine.date starting from 2023, and time end equals to earthengine.date 2024. There it is. And now I'm going to calculate the differences between time start and time end, because first of all I'm going to make a list including all the dates in which we must have a Sentinel data. That's why the differences should be calculated. Here Time difference is another variable equals to from time end. I'm gonna calculate the differences between time end and time start here, and then based on what kind of unit, the unit will be day. I'm gonna calculate the number of days we have from time start to time end. So if you print of time difference in the right panel, you can see we have 365 days difference from time start to the time end. So now in the next step, I'm gonna make a list here. For example, here a new variable as list is created, earth_engine.list.sequence. So here I'm gonna have a list of sequences, a list of numbers starting from 0 to what we have to the number showing by time difference. Here earth_engine.number time difference. So as we are starting from 0, it is important to subtract the time end from 1. That's why I'm subtracting from 1. And the step could be, for example, 5. As we have 5 days temporal resolution between each sentinel data potentially. That's why the step should be number 5. So here, if I print the list, then you will see a list of numbers starting from 0 to 360 with 5 intervals. As you can see, finally, we should have 73 elements with 5-day interval. But this is just only a list of numbers. Now I'm gonna add the date instead of each number here, or I'm gonna replace each number with the date starting from time start and ends to time end, just like that. Make a new loop structure using the map, and then we will have a function. Each input number will be just a number, just like that. Then function returning. So function returning each number. Instead of each number, I'm gonna have the dates information, the origin of the dates already stored in the time start variable. And now I'm gonna calculate from time start toward time end with 5 days interval. So that advance allows me to go forward from time start and based on the delta. The delta here will be the number because this explaining the differences with a specific interval from time start to time end based on the units. So that should be days, just like that. So if you run a code again in the right panel, you will have a same list with 73 elements, but instead of, however, this time instead of having normal numbers, here you have dates starting from origin and ends to the end of December 2023. There it is. So now this list is going to help us in the next step to filter Sentinel-2 data based on each 5 days temporal frequency, and then we want to do mosaicing process using this kind of list and time period we want to create here. So here make another variable as Sentinel-2 mosaic, just like that, equals to earth_engine.image collection. First of all, put everything inside an image collection because the input is a list of values, but we want to output with image collection nature or characteristic. So make a list and then define a loop. In the loop structure, I'm gonna actually already I have the start date for the temporal frequency, but I need to have the end date for each temporal frequency. For each 5 days, I need actually a time start and a time end. Its time start already defined here, and the time end must be defined in a function. So now the inputs to the function are a list of dates. So here I have dates, and now a new variable created as date again, Earth engine.dates to dates. So meaning that or we can change it to a start date. Yes, a start date is better because for each 5 days, the start date already explained here. So now we want to have end dates for each 5 days period. So end date equals to from start date, I must go forward using that advance based on 5-day interval. The delta will be 5, and the interval is based on the days, and I skip the time zone just like that. So the time is the start date and end date for each 5 days defined through the loop structure, and then we must bring Sentinel-2 data here. For example, I have the IMG for the mosaicing process, in which each Sentinel-2 will be filtered based on start date and end date. So meaning that I'm gonna actually select all Sentinel-2 data available for the region every 5 days. And that's how it works. And then after all images selected for every 5 days, I must do the mosaicing process using .mosaic that you can see here. This is a very, very simple technique. Finally, the function returns the mosaic image with a new system time start and new system time end that already explained using start date and end date here. The new system time start is like that, system time start date, and I will have a new system time end equals to end date. As the Earth engine uses the millisecond structure, you must convert start and end days to millisecond formats. So just like that, as you can see, the mosaic image created. So now I'm gonna make sure if everything is right or not. If there is any syntax or problem on my code, just make a print to see the code how it works. So print Sentinel-2 mosaic, just like that. And in the right panel, we will have a new image collection with 73 elements. As you remember, previously we had 73 elements in a list. Now we have 73 elements in an image collection structure, and each one of them including each image that is mosaic according to 5-day intervals, as you can see, including 26 bands that I'm gonna choose visible and near infrared bands. Sorry. So as you can see here, I'm gonna use .select to select the target band. For example, I need bands from band 2 to 4 and also band number 8. These are my target bands, visible and near infrared, that can be used for the visualization process and etc. So save the code and now run it again. Finally, here you can see in the right panel only 4 images selected for each date separately. So now I have a visible and near infrared bands for each 5 days mosaic already. So now I'm gonna actually visualize the output to show you now what's the differences between mosaic image and also the original data we had at first. So just use map.addLayer for the visualization. This is a popular function, allows you to do the visualization easily. Couple of arguments here we have. One of them is a Sentinel-2 mosaic. This is the mosaic version. Now I'm gonna actually select only 1 or 2, or for example, I'm gonna select only 1 image for example 1 month in this region. Dot filter Earth engine.filter.calendar range. Calendar range is a popular function allows you to select or filter the data based on a month, day, hour, minute. It's very useful things you can use here. For example, a couple of arguments we have here. The start one, for example, I'm gonna select the August as a start month and August as an end month. And here the field could be anything at any time or temporal unit, but here I'm going to use the months to select the first image that is available in the August that is already mosaic for the region of interest. So leave the visualization parameters empty, or even you can here let me to do something different. For example, imagine that, let me to do it in another way. For example, I'm gonna select only one band. Imagine that the band number 8 is a target band I'm gonna use here, and then throw the dot to bands. Now I can actually make a stack layer including all actually near infrared bands available for the whole of the year with 5 days interval. In this case, you can compare the images from one day to another instead of the previous compared to previous example I wanted to show you here. And also the layer name, the visualization parameter could be empty, and the layer name is the mosaic image, and skip the opacity here. So mosaic is enough. So another map.add layer for the previous layer. So map.add layer sentinel2 that selects band number 8. As we have a large number of images, around 1000 data, it is better to limit your data to only for the original version to only one particular month for the comparison. For example, here I can select band number 8 first, just like this, and then filter it based on the Earth engine that filter that calendar range. That calendar range here, the start date is, for example, August is a target band for the comparison, and the field could be also the months, just like this. And then I need to make a stack layer from all August near infrared bands we have, and then leave the visualization parameter empty, and the layer name will be original, and use the false at the end to avoid automatic visualization, just like this. And let me to do this for the and also we need to use the same calendar range for the mosaic image. As you can see here, just copy and paste it just like this. Remember to save your code and run it again. So here now you have two new layers, one of them mosaic layer and another one the original layer, both of them related to August 2023. Here check on the original layer and go to the layer second here, and here you can browse different bands. For example, one of them selected. These are all near infrared images available for the August 23. Click on apply, and after a few moments you can see that band or that image only covers a particular region from our region of interest. So, and now I'm gonna see what's happened in the mosaic layer, but as you can see, the mosaic layer covered a whole region of interest completely. For example, one of the images selected, and here click on apply, and you can see it is mosaics for the region of interest, and it will be easier to clip your data based on the region of interest. For example, here after making a layer stack using two bands, you can clip it based on the ROI. You can do it for both of the layers. Clip based on ROI. Run a code again, and here you will have mosaic version that covered your region of interest easily. with high quality. Increase the contrast using 90% of values and then click on apply. Here, this is the mosaic layer, but as you can see, part of this region is cloudy for this mount. You can try with different bands and see how it is working. Here it is. As you can see, it is covering your region of interest completely with a high quality. And then in the original layer, for example, one of the images selected, then increase the contrast by 90% of values and click on apply again. Now you can see only a small part of your region covered in this image, because this image belongs to another region, only a part of it included in this region of interest. This is another image. You can see only a part of that image covering your region of interest. So now the problem is solved and you learned how to do the mosaicing process. This code can be used for all around the world, and also you can use this code for the Landsat data. The only thing will change for Landsat is related to the kind of image collection and the band names you are using here, but everything is same for the Landsat and Sentinel-2 data. And also maybe some sort of coarse spatial resolution data sometimes needed some sort of mosaicing process. This code again can be used for all the satellite data that have framing structure in the Earth Engine platform. The code is also available below the video on my YouTube channel in the description box. Please feel free to reach me out and ask your question about the Google Earth Engine platform. I will be happy to get in touch and answer your question as soon as possible. Have a good time.